So with that, welcome to From Data to Action, Individualizing Math Supports to Meet Student Needs. We're excited to have a great group of presenters here for us for this webinar. So I don't want to take a lot of this time. So I'm just going to briefly introduce the three presenters that we have here today. First up, I've got Dr. Sarah Powell. She's a professor in the College of Education at the University of Texas at Austin and an associate director of the Meadows Center for Preventing Educational Risk. And then next up, we've got Dr. Erica Lemke. She's a professor in the Department of Special Education and the Associate Dean of Research in the College of Education and Human Development at the University of Missouri. And then finally, we have Dr. Bradley Witzel. He's the Adele Worth Daniels Distinguished Professor of Education at Western Carolina University. And with that, I'm going to turn it over to Brad and go ahead and get us started on the webinar today.
Absolutely. As the token male, it's great to see you all. I'm excited to get us started. Hey, listen, when we're talking about database supports, this is one of the most important things we can do, particularly in mathematics education. Here's some of the things we're going to talk about today. First, we're going to start out with evidence and research. We're then going to dive into the framework, the instructional platform, how progress monitoring can work, and then, of course, the diagnostics. Who would forget the diagnostics in math? We're going to make sure that we leave you with some of the next steps of what to do now that you get all the information, what happens next, and then, of course, some good resources. So let's get started with evidence and research. Now, I tell you, this is one of the fun things for me as a person who's getting a little long in the tooth. How many of these have you seen before, and what do they have in common? Let's give you a second. If you're with friends, you can chuckle. If not, you can say, oh my gosh, Brad, I know those. So in the chat, someone else, I don't know, Erica and Sarah are ready to go, but you can write in there and say what they have in common. Remember though, if your first inclination is say, yeah, none of those stuff ended up working, well, don't go too far. We were trying to solve problems in education. And so I really don't look down on these, but what happened was we got really excited by things like brain gym and multiple intelligences, learning styles. We got so excited that before the data came in on random control trial studies, we jumped. We said, oh my gosh, we got to try this. And then many people were left disappointed. If, however, you are the person who says, oh my gosh, actually, I tried that. I know the data isn't good, but I tried it. It really works for me. It probably isn't that skill that you did or that approach. It probably is you. You probably infused some amazing strategies to make that work. So what we're going to talk about is things that work across the board, things that we know are supported by research. So let's dive into some of those quotes that we read. Now, I have a gorgeous, wonderful wife who loves to read research and read it out to me, one study at a time. But I want to make sure that we dive into the methods section. So this is called publication bias, things that just get published because they have outcomes. This was a review of research, not a meta-analysis, a review of research. And I wanted you to see just what was written in the methodology. They concluded this grand thing that you can't ever do, never do this. And I won't even talk about it because look at what they wrote in their methods. And I'll read it quotes in case you're just not here to read. Lastly, we excluded studies on multidisciplinary domains beyond math or studies, here's the big deal, that used math achievement as the sole source of connection to math ed. Guys, in other words, they did a review of research of articles on mathematics that had no outcomes in mathematics. These were other things such as affect or if the kids liked it. So be cautious just grabbing whatever the researchers say. You've got to read the method section. Take a look at this one. This is a very popular book. And in this popular book, a lot of people say, wow, it's based on research. Well, I want you to read one of the clips that he wrote in his research. Whether we group students strategically or we let students form their own groups, we found that 80%, that's a nice round big number, 80% of students enter the groups with the mindset that, well, our job is not to think. Now, right there, I've already got questions. Wait a second. Who's defined thinking here? Well, he did. He defined his own thinking. However, when we formed the visible random groups, the things he's selling you, within 6 weeks, 100% of the students said, wow, I am here to think and to contribute. Guys, if you get big round numbers like that, have a lot of caution, look for definitions, and how did you operationalize thinking? How did you operationalize going to contribute? And what assessments were being used? All right. The last one here is kind of funny for me. Another very popular person, and this is in the publications. Two things here. The first one, This person cites Jason Mosier's work on neural mechanisms. And fascinating work, by the way. Read the original research, please. But he said Mosier and his group found something fascinating. When we make a mistake, get ready, synapses fire. If you have the background, guys, get ready. This person said synapse is an electrical signal, but it's not. It is actually just a space pocket between cells where messages are posted. Further, they said, look at what we've learned is that making mistake is a very good thing. That is not what Moser's work was. In fact, Moser said, you better catch errors early before that mistake is practiced. And this is the big deal. Remember, learning does occur during mistakes. They're called errors. And if you repeat errors again and again, that's what they know how to do. So be cautious on what we call research. Dive into what the research is before we start reading these books and these quotes and these position papers. Dive to make sure the research is supporting it. Okay, case studies and position papers are important. They help drive the conversations. They end up building into a lot of what becomes research, but they then themselves are not research. Moderate level survey data, single case design, good ideas. And again, we want to get big. Sometimes you can't get bigger than a single case, but these start good conversations. What we're looking for are systematic reviews and meta-analyses, random control trial studies, and quasi-experimental studies. These three are the ones we should lean on when trying to determine what to do to help students in mathematics. So if you're looking for those, like, hey guys, where do I find these? A good place to start is just do a little search for IES practice guides. IES, the Institute of Education Sciences. This is the research branch for the U.S. Department of Ed. And we're just going to show some of these up here. They'll even tell you what the level of evidence that it is in there, right? From encouraging young ladies in math and science. And by the way, young ladies do well in math. They just tend not to take upper level courses. As a dad of two girls who are adult-ish and doing very well, yeah, just keep encouraging. But there's lots of good practice guides out there. And there's things in there that you might have been told don't work. Read the research and find out that they do work and what works in mathematics. So again, go find the good stuff and really dive into what works in mathematics.
So I'm going to pick it up from there. Thanks so much. A wonderful introduction, Brad, to sort of how we should be thinking about this evidence. And we're going to move right into our next step, where we're going to talk about the database decision-making, or DBDM framework. A lot of you have probably used a framework like this. Maybe you called it like DBI, data-based instruction, data-based individualization. Sometimes we even call it like problem-solving model. But there's some key features that make it a really important framework for you all to be using in your classrooms with your students, even in your schools and districts. The model that you see here is from the National Center on Intensive Intervention, and it is a commonly referred to model. You're gonna keep seeing this as we go along today, but it includes both elements of assessment and instruction. DBI, or DBDM, database decision-making, really has some hallmark key features. So it's a systematic process. Obviously, from the title, we're relying on data, good objective data, and it really helps us narrow in and individualize instruction for students. I'm sure a lot of you right now have students who are very unique, and we need to know what those unique features are. This model really helps us sort of narrow in and individualize or intensify instruction. As I mentioned previously, we have assessment elements of this framework in orange. Those intervention or instructional elements are in green. And then probably the most important piece of this is decision making. So how do teachers take these elements and then make decisions accordingly? How do they look at that progress monitoring data and decide, is this instruction working for students? That is, are they responsive to that instruction, or do I need to make a change? So DBDM, as we think about it, you've heard me calling it a framework. That's a really good way to describe it. It's a process of examining ongoing assessment and intervention, how those two work together, how they relate together. But it is not a single intervention. We don't say, oh, we just DBDM them, like that was my intervention. It's not a single assessment. We really want to think of it as that process. So a few key characteristics of database decision-making. And this really links back to some of the highlights that Brad gave at the start of our conversation today. It really helps us be mindful about those evidence-based practices. So we're thinking about, we started out with a high quality evidence-based practice. How is that going for this student or this small group of students? It helps us be more nimble, if you will, looking at data, making decisions. We know from the research that when teachers are making more timely and appropriate decisions, student achievement increases. And so that is so powerful to have in your toolbox. We also know that we can use DBDM across the settings. This isn't just something for special education. We really want to think about how we can use this across settings and honestly across both academic and behavioral areas. There is lots of support for the use of database decision-making, database individualization, everything from, there we see that again, meta-analysis. Brad just referred to that. That's a key one that we need to be looking at. When we see that meta-analysis, we know that's something important around database decision-making that we need to pay attention to. Upcoming, here's another example. This example was from some work that we did in early writing and thinking about how you can apply that database individualization model to subjects like early writing. Sarah and I are currently doing a study in middle school mathematics using that DBI or DBDM framework. And so we're going to just briefly kind of go down through like what are each of the basic steps in this framework, in this DBDM model. Our first step is to be thinking about, do we have an established, validated instructional platform? What is already happening at the universal level, at tier 2, if you have a tier 2 platform? And is that validated? And that's a key word. That means, is it proven? Is it evidence-based? We don't want to just put, sometimes we say little tier 3 Band-Aids all over everything. We want to make sure that we start with something that's validated so that we know that that was in effect for everybody from the start. And then next, we're going to go in, we're going to start thinking about that routine of progress monitoring. When I talk about progress monitoring here, I'm talking about using a CBM or a curriculum-based measurement model, using short duration, valid, reliable measures. There's great tools charts on intensiveintervention.org, our NCII website, to give us a sense of those validated CBM measures. And we're going to collect data weekly, most likely, to be able to create a graph of student progress across time. Then we're going to work with our team to look at that data. This could be your middle school interdisciplinary team. This could be your high school content team. This could be your elementary problem solving team. But you're going to look at that data and set up a routine to make decisions as you look at how the data compares to the goal that was set. And then finally, if we need to make an instructional adaptation, if the data is saying, ooh, yeah, this isn't quite going how we thought, we need to make a change, we're going to look at some of that diagnostic data to help inform what that change should be. And then finally, we're going to continue that routine. We're going to continue that cycle as we go throughout the time that we're working with the student. That could be throughout the IEP cycle, could be throughout the time we have the student, just during the year. It could be a student who's not on an IEP, and we've set up that plan for them and we continue to monitor. So that's some kind of basics about the framework. And now Sarah's going to talk a little bit more about how that instructional platform that I referred to, how that starts to enter in.
Yeah, thanks so much, Erica. So now we're going to launch into that jumping off point for the database decision making or DBDM model, and that is that instructional platform. Now, Brad just a few minutes ago talked about the importance of relying on research and then the evidence that comes from that research. And he shared some IES practice guides, which are just one really nice resource to access to tell us about, well, what are some of the important things that we should be thinking about as we design an instructional platform. And we're talking about math today, but you could also think about designing an instructional platform in other content areas as well. And so we are going to think about, well, what would an instructional platform look like? That instructional platform should be full of those research validated or evidence-based practices that have been shown time and time again to be really, really important for improving math outcomes. And so I'm going to show you an example of an instructional platform that we've been using with some teachers that we've been working with in Texas. And I'm pulling a lot of those ideas from this IES practice guide that you see here on the left-hand side. This was one of the more recent IES practice guides that did come out in March of 2021. You can access it on the What Works Clearinghouse website or the IES website. And there they share 6 really important things for supporting students who struggle with math in the elementary grades. And right now I'm going to show you how we've taken those 6 practices and put them into 5 practices so that we could think about how could teachers design this instructional platform that relies on evidence, but that can also be practically implemented in the classroom. So as we get to thinking about that instructional platform is that jumping off point that really kicks off this whole database decision-making framework. And as I think Erica has emphasized and Brad has emphasized, we want to make sure that this platform is comprised of research-validated practices that have been shown over time and with multiple students to lead to improved outcomes for students. And so I'm focusing right here on the very top of our database decision-making framework. Now, I said I was going to share with you the instructional platform that we've been using with teachers in Texas. Texas is where I live and I work with a lot of teachers there. So I'm going to share with you some materials from our project, which we call Math Spiral. And we have been working with teachers on 5 big components within an instructional platform. And each of those 5 components have a strong evidence base to support their use. So what are these 5 components? Well, the first thing that we've been talking with teachers that's really essential within that instructional platform is to make sure that as we're teaching new content or as we're teaching content where students have struggled previously, that we want to make sure that we're using very explicit instruction. So we have been relying on this model of explicit instruction that if you have tuned into other webinars from the NCII or accessed other materials from intensiveintervention.org, you've probably seen this model before. It's that combination of modeling and practice within those supports that occur during both modeling and practice. So as we think about how teachers put together a really cohesive instructional platform, the first thing we always talk about with teachers is explicit instruction. So how are you modeling? How are you engaging students in practice? And then how are you supporting students as they model and practice? And some of the common supports we've been talking about are you asking students a lot of questions? Are you getting students to frequently respond? And then are you providing feedback to those responses? A second big idea from the instructional platform that also has a strong evidence base to support its use is to pay attention to the vocabulary of mathematics. So within our project Spiral, we've provided teachers with math glossaries and word wall cards, in addition to a number of different activities and games that students can use to increase their knowledge of math vocabulary. And it's not only increasing their knowledge of the math vocabulary terms, but also developing a deep understanding of what each of these vocabulary terms means. So that's our second component of our instructional platform. A third component of the instructional platform that we've been working on is this idea that students need to see math in a lot of different ways to develop that deep understanding of math. So we call this a focus on multiple representations. And for us, this encompasses 2 of the practices from that 2021 IES practice guide. They said it's really important to use representations and it's really important to focus on number lines. I see number lines as one of the types of representations. So we've just placed number lines into that representations category. But as we've worked with our teachers thinking about, well, what would your instructional platform look like with a focus on representations? Here, probably no surprise to any of you who spend any time in the math world, we're talking a lot about what are some of the concrete materials you can use to help students deepen their math knowledge? What are some of the pictorial representations that you can use and students can draw, including a number line? Pictorial also encompasses that whole world of virtual manipulatives that are available now. And then how do we do all of those things so that we can really help students understand mathematics in the abstract? As we continue with the instructional platform, one thing that we've been working on is how do we help students build fluency in mathematics? So here you can see some of the key ideas about building fluency, but we most often emphasize that fluency is that ease and accuracy with math. And so as students develop the foundational knowledge or foundational content through the explicit instruction, vocabulary, and use of representations, then it's important to help move students intentionally toward a place where they're developing that proficiency or that fluency so that they have ease and accuracy with that content. And then the fifth part of the instructional platform, which if you know me is probably no surprise, but a focus on word problem solving. So in Spiral, we've been talking with our teachers about how to integrate the use of an attack strategy, such as UPS check that you see here, and then how to use that alongside those word problem schemas. Those word problem schemas are those concepts that we see embedded in word problems time and time and time again. And so to help students recognize those schemas and then be able to solve a word problem according to schema is a really important part of the instructional platform. So there we've taken those evidence-based practices and we've put them into this instructional platform where we've encouraged our teachers to ask themselves, am I doing these 5 things every time I'm teaching math? So am I teaching explicitly? Am I emphasizing the vocabulary of math? Am I using representations to help students understand what the math means? Are we helping students build fluency? And are we practicing problem solving every day we teach math? And we see that if we start with that instructional platform full of those evidence-based practices, it's not a guarantee that it's going to work for all students, but it's a pretty good starting point. And that's why we call it the platform. It's the jumping off point for our database decision-making framework. And it's just a good place for us to start. So that was just a brief review of the instructional platform and how you might conceptualize some of the components that should go into that instructional platform. So I'm now going to turn it back over to Erica, who's going to talk about progress monitoring. So we've got the platform and the question is, does it work? So take it away, Erica.
Yeah, absolutely. Thank you. And a nice segue into this next part. And as we think about database decision making, it's really critical that you have ongoing progress data to help support your good decisions that you're making. And so you see progress data represented a couple of times in this framework because of that, because of the importance, because of the interest in making sure that we make a valid and reliable decision. Honestly, for our kids who have difficulties, for our kids who are on IEPs, we don't have time to wait. And so we need to make sure we're using tools that we have confidence in. As we think about progress monitoring, there are many health metaphors that we typically use. These are nice because it helps you explain to others the kind of measure you're using. So you might have used things like step trackers, or my son has a Whoop that keeps track of some of his health data. You might think about a growth chart when you go and you visit the doctor with a young child or a baby. They have typical sort of growth charts, and it gives you an indication of how this child that you're bringing in compares overall to other children that have about the same age and the same gender. You get a sense of, for instance, on a utility bill, a sense of how much energy you're using. When you step on the scale, It gives you an indication of your health. All of these things are indicators, just like progress monitoring is an indication of a child's academic success. As we collect that progress monitoring data, we're then looking at the data and in graphical form, as I talked about earlier, to determine whether the student that we're working with is responsive or non-responsive to the instruction or intervention we're providing. As Sarah mentioned, we want to start out with something that's evidence-based, that we can be confident in, but we know that's not always going to work for everyone. And so it's important for us to dig into data and make sure we're creating the best program for each student with whom we work. So here's an example of a very basic progress monitoring graph. This is Sophia. The first step is to collect some baseline data. So we're collecting, in this case, it was 5 points. Sometimes it's as few as 3 data points. This could be in any subject area right now. Like you'll see over on the access, we have just scores. So this could be reading data, mathematics data. But we're setting a goal, and this goal is indicated on this graph by an aim line, that red line that you see. And usually those goals are set using established norms with the progress monitoring program or tool that you're working with. Then we implement an intervention. Again, we're drawing from those interventions that are most evidence-based, and we continue to monitor the progress of the student during intervention by giving them one of these curriculum-based measurement measures each week. Again, in reading, excuse me, we're thinking about like a very short duration, a 1 minute sample of oral reading. And we're graphing how many words the student reads correctly in 1 minute. In mathematics, we're thinking about a 2-minute computation measure where a student answers mixed computation problems, and we graph how many digits correct the student had in 2 minutes. We're monitoring progress, and then perhaps, as I mentioned before, perhaps most importantly, we're applying some decision-making rules to help us determine how this student is doing. So let's see how Sophia is doing in terms of her growth compared to the goal line set. So let's look a little bit more at that decision-making. So here's an example of a graph. And on this graph, you can see the green line is the goal line for the student. This particular graph was from a writing tool, from a picture word writing tool. The dotted line, the blue line, is the trend of the data. And you all might remember that sort of, in very non-scientific terms, we're taking all of this data and we're sort of squishing it on a line of best fit. Statistically, we're actually finding the line of slope, essentially, of all of that data. We know our students don't always have perfectly linear data. There's some peaks and valleys. And so we're trying to make sense of that data. As we look at this data, we're comparing that trend of data, that dotted blue line, versus the goal line, that green line. And we're asking questions like, is the student making progress toward the goal? Is the intervention meeting the student's needs? As you look at this trend, the dotted blue line and the goal line, they're almost like parallel. They're like meeting. The student is right on track with the goal. Maybe we would like to see a little bit stronger increase, but right now things are going well. In this case, we would stay the course. Whatever we're doing right now seems to be working pretty well for the student. As we're considering how to look at and make sense of this data, want to continue to emphasize the use of graphing. I know sometimes graphing can be kind of daunting, can be make people a little nervous, to think about like taking on a technological tool. Honestly, like there are lots of great ways using, Excel, for instance, to graph, but like if you need to pull out just a paper pencil graph and graph data that way, no problem. Like it's no problem. Don't let that slow you down. But I will say on the NCII website, they have a really great graphing tool. It's developed by Devin Kearns, our colleague at North Carolina, NC State, I believe. And if you just Google or search on the NCII website graphing tool, you'll find that really easy. You just have to enter the dates and the score, and it does all the work for you. So use those graphs as you consider your decision-making framework. Really important picture of student progress to share with other teachers, to share with parents, and perhaps even the student themselves. Here is an example of one of the graphing programs we've used in the past. This was for some math data. And I want to jump back real quick then to a decision-making, oh, you can go ahead, thank you, to a decision-making framework or rubric that you might use as you consider that graph data. So again, you're going to examine that trend line. That's the line of best fit for your data, the line of slope for your data. You're going to compare that to the goal line. At this point, you have three choices. If the trend line is steeper than the goal line, that's awesome. The student's growing even better than we thought they would with this particular intervention. We might need to even increase the goal. Things are going great. If this continues, we might be able to actually reduce support for the student. If the trend line is even, we saw this example with Sophia's graph, then we're going to stay the course. We're going to continue to watch that trend because there may be, in a couple of weeks, we may see a change in that trend, but we're going to continue to watch. We're going to just continue to do what we're doing. Whatever we're doing seems to be working well, and they're meeting that goal. If the trend line is flatter than the goal line, now we need to stop and consider, is the intervention working for the student? And before we make a change, we want to first think about, was it implemented with fidelity? Was it administered as intended? We want to think about the treatment integrity. So it could be that it's a 30-minute intervention and every day we're wrapping up about 20 minutes in. So we want to go back and ask those hard questions that help us learn more about whether we just need to improve fidelity of the intervention or if we actually need to make a change. So here's an example, if you wouldn't mind, Sarah, just you can bring that all up. There you go. Thank you so much. So here's an example, again, of a graph. There's that baseline again, and we've set the goal for the student. That green line is the goal that we've set. The red and green data points that are connected now in this case during intervention 1 and intervention 2 give us a sense of how students are performing. If we take the case of this particular student, in intervention 1, when you look at the trend of data, that's that white line establishing sort of the line of best fit. When we compare that trend to the goal, you could be thinking about, what is that telling us? If we look at in intervention 1, that trend of data compared to the goal line, what would be your decision? Okay, and then, sorry, I'll just go back real quick one more time, Sarah. Sorry about that. And then in intervention 2, again, we look at that trend versus the goal line. The trend of data is capturing the data that is in those green data points. And in this case, you can see that the decision here would be to continue as is. I gave you a little wait time for intervention 1, but the decision was to make a change in instruction because trend was less steep than the goal line in intervention 1. Intervention 2, we're back on track. The trend is the same. We're going to continue as is. And that step 4, evaluating and modifying based on looking at progress compared to the goal line, those are those key decision-making points that you saw earlier in that rubric. So again, DBI and DBDM really relies on those progress monitoring points. You want a high quality curriculum-based measurement, progress monitoring system. Again, Great place to take a look at those is on the tools chart on NCII. And we want great decision-making rules. Teachers are wonderful about trying and giving 150% before they make a change in instruction, but it's important to set a system of decision-making and stick with it. Because sometimes we stick with things too long, and then we wish we would have gone back a few weeks before that and made a change. So you want to pick that decision-making rule. You want to apply that rule as often as you have suggested. Typically, every 4 to 6 weeks in academic areas, you're applying that decision-making rule. And so that's a little bit about the progress monitoring piece, but it has to go hand in hand with diagnostics to help inform what's going to happen, what kind of change you're going to make, what sort of skill you might need to focus on next. So Brad's going to talk a little bit more about diagnostics.
Yeah, and it used to be a time, right, when we put every poor child through a key math, right? Remember those days? Oh my gosh. There are smarter ways to do that. So we're going to actually talk about where a diagnostic can be used, and we're going to choose more of a formative assessment diagnostic to support this. Now, again, we're not trying to replace a hardcore standardized diagnostic, but we've got to find something that's more efficient that can inform our instruction immediately. So let's talk about diagnostic data. Now, we have to start with a task analysis, and that feels weird, but you have to know what the expectation is. So I know it sounds funny. Sarah said it earlier. Erica's been emphasizing it, but as I make the joke frequently, this just in, math has steps. And steps come with reasoning and prosody. So we need to always connect whatever mathematical step you are wanting students to do, make sure it comes with reasoning. Don't separate them out, connect it. To do that, task analyze what you're teaching. What is the expectation and how do you teach it with a level of complexity that matches the needs of the student and, sadly, probably your assessment? One, start with identifying the standard. What construct is the student supposed to learn, and at what level of complexity is the student supposed to learn it? Next, for you in your preparations, choose a math problem of that expected complexity and work it out. Work through that construct. Think of all the steps with reasoning that you teach. This just in, if you're teaching something without reasoning, go back and try to find another way to do it, right? How many of us learn tricks rather than the actual mathematics? So go back and undo that. Then, when you solve the problem in this stepwise manner, like I said, put a reason with each step. Think of it as a T-chart of step, reason, step, reason, step, reason. If proofs in geometry were something that caused you great pain and distress, I'm really sorry, but that is what mathematics is. All right, challenge yourselves, do some alternatives. Try to see when your steps aren't going to work and really work through, okay, is my step generalized enough to show how this works across a myriad of problems, or do my steps only work for this specific problem? You want to try to minimize the steps so they become general. Just a couple examples here, because I am a math geek, so I want to play with some examples. So this is multi-digit subtraction, right? So I've got my minuend is 325, right? And I'm trying to take, and I'm trying to look through what do I do with my subtrahend? So I'm going to take each one and I'm going to decompose them. So I'm going to have my minuend of 325 down to 300s, 2 10s, 5 1s. And when I'm subtracting that subtrahend, it's 100, 4 10s, 8 1s. Do notice that when you look in there, it's a negative sign in front of the hundreds, tens, and ones. That's important because a lot of the times we subtract, but you put positive signs in there. We must teach that this is subtraction. Now, when you're regrouping, you don't say you can't take 4 10s from 2 1s and you can't take 8 from 5. Yes, you can. In fact, if we were to do this Brad's way with my own family and the teachers I work with, I would go 300 minus 100 is 200. 2 10s minus 4 10s is negative 2 10s, and 5 minus 8 is negative 3. I wouldn't do that. But if you are going to help your students who do not have a background in the number line, they only know of a number array, then help them and say, hey, listen, you haven't learned how to take 4 10s from 2 10s, and you haven't learned how to take 8 1s from 5 1s yet. Therefore, let's reorganize and decompose that one of the hundreds from 200. Now we've decomposed it so that it is 200s plus 11 10s plus 15 1s. And now I can subtract. right? That allows that step there. So I've got a 4-step process. Just know that one of those steps requires more of the cognition and background knowledge. Now, if you're working on students, and a lot of us think, I've heard this before, right? I work with early childhood grades, are like, but all I teach is don't think that. These are hard things for a young person to learn. So this is single digit addition, and you're thinking, oh my gosh, you just take one and add it. No, it's bigger, right? Those of us who taught this, we know what this means. So let's take the problem 2 plus 5. You're going to first have the student identify what is the problem asking. In this case, it's addition. All right, what's that first add-in? It's 2. I'm a number line fan. You heard Sarah talk about it with the practice guides and what Erica is working on as well. So let's identify 2 on the number line. We're going to go there on the number line. Identify the addition and the second add-in, which is a positive 5. I'm going to move that many steps forward. So we go from 2, 3, 4, 5, 6, 7. Then say the number where you arrive. 2 plus 5 is 7. That is another approach. And of course, you see it's digits, D-I-G-I-T-S. Now, I make that known for that acrostic in mnemonics because if you're in the middle school, high school world, we live off this stuff, right? Because there's so many wild things. You're like, it is beyond the working memory of my students. So I've got to try to figure words that help my students memorize these steps. So solving equations is isolate. And each one of those letters tells a student what the activity is. Slope intercept form, which is no easy feat. Rise, run. And I know out there, my math geek friends are all like, rise, run, don't we want to get away from that? But it's not what they're doing. It's the acronym to know what the steps are when I'm teaching reasoning. And quadratics are for factoring. But again, I take those steps and I break down what my instruction is with a verb to help them remember what those steps are. Now, what are we going to do with that? So we're going to take that same addition problem and I'm going to break it down so I can actually give feedback specific to students. So I've got my fake students here. We have to fit them all on a sheet. And I'm a guy who still walks around with a clipboard, right? And I'm checking off, all right, show me step number 1 on your board, 2 hands on board, forehead. That's where their first step is. They have to decompose that. In this case, it was the subtraction. So they have to decompose the minuend. Next, I asked them to regroup and then decompose one of the place values. So look at my data, 2 hands on board, to forehead, show me what you got. Jack did it right, but Bill had an error there, Kelly had an error, and then Javon had an error. That might trigger me to stop right there and reteach. Now, continuing on though, I'd ask them to do the next step. Think about it. If Bill had the prior step wrong, it might look like their subtraction is wrong too. You have to base the next step on what they've done. All right. When you're done with this, you can see it looks like, oh my gosh, more of my students in this set had errors than successes. That's just not true. If you're only looking at the answer, you're losing the sight of what the mathematics we want them to do. There's a lot of work here in mathematics. Now, instead of turning to Bill and saying wrong answer, I get to go to Bill and say, hey, look at this. You decomposed correctly. The subtraction you did was correct. You added all the differences correctly. And then, but I got the answer wrong. No, you think you can do multi-digit subtraction. We need to focus on regrouping. We have to talk about how we're going to decompose a place value across different place values to support your subtraction. Or I'll find an alternative method for them. But this is a diagnostic approach. This formative diagnostic checklist allows you to dive into what the students are doing correctly first, and then how to help them clean up that error second. And in this case, it's an easier one because none of my students have repeated errors. It's one error to focus on, which means I get to celebrate what they're doing and then dive into how to help them out. Now, in this case, 3 students have a need. I need to find time to pull those students aside and give them quick support before they practice that error. So we have taken a lot of these big ideas and helped them understand how to drive the database supports. What we're going to do now is talk about what are your next steps to make this happen in your world.
Yeah, thanks, Brad. We tried to kind of boil down, if you will, some next steps. I know sometimes you listen into these things and then like you step away and you have so many things on your plate that it's hard to go back and decide like how to move forward on this. So we try to give you a few ideas about how you might do that. And I'd encourage you as you think about this webinar today, as you look at these slides, I'd encourage you to make a few notes. If you're working with a team or a small group of teachers that you're building today, or if you're all on the webinar, maybe you could regroup briefly in the next few days and try to think about even just some small next steps. So as we think about those next steps, one piece would be identifying, let's say that DBDM is pretty new to you, or it's new to you in the area of mathematics, for instance, and you want to get started. And so the first step might be starting small. You might identify a student or a small group of students. You might identify a grade level or a content area that you want to work with. And you're going to decide who these students are and how you're going to start a system of database decision making. You're going to collect some data from initial progress monitoring. Sorry, back just one more, Sarah, sorry about that. And you should look at those tools charts. There are free measures that you can use to get started if you don't want to invest a lot of money in this. And you're going to pick the measure that's based on the student's skill needs. We have measures in things like in math, in areas like early numeracy, computation, concepts and applications. So you should decide what foundational skill is the most difficult for students, and you want to start your progress monitoring there. Okay, then next, as you get going, you're going to administer some screening, or sometimes we call those benchmark measures to each student. The administration directions are provided by the particular company that you pick to provide these measures. Sometimes you do it using paper pencil. Sometimes they're on the computer. It just depends on how much you want to invest in this. And then you're going to score and graph that baseline data. Again, typically that's like 3 measures given either back to back, if it's really short measures, or it could be within 1 week. You would give these measures and graph that data. Then you're going to set a goal for students. I know there was in the comments, there were some questions about goal setting. You're going to use the established levels or the norm or normative values that are developed by the company that developed the system that you're using for progress monitoring. So don't use your own made up norms. You want to first look to see if there are norms developed for that particular product. And you want to think about setting up that progress monitoring level at the student's instructional level. So a couple of you had great questions about progress monitoring at the secondary level. I want you to think about, even though like you might have a tendency to want to progress monitor in calculus or pre-calc, like you want to think about the instructional level that a student's at and what foundational mathematics concepts they might be missing. And then you want to jump back down to that level. For some of our middle and high school students, we're going to be jumping back down to like a 4th or 5th grade level in some cases. And you want to choose measures that are at that instructional level. You're going to give those weekly. That's best practice for students who have math difficulties. We need that frequent ongoing data. You're going to score and graph that data, again, using either your electronic graphing program or a paper pencil graph. And then typically, best practice would be after 6 data points, you're going to use that decision-making flow chart. You saw a nice example of that I showed. You can access these slides, and so that might help you continue to use that. And you're going to decide if you stay the course, if you raise the goal, or if you make an instructional adaptation. Someone, I think Vicky in the chat commented, this data is highly connected to informing teachers' instruction. So this is not yet another data point that says, yeah, I knew, Sophia, she was low. Yep, just confirmed it. She's low. We want to provide that data so that teachers can use it to adapt their instruction. It's as much or more for teachers than it is actually for students. All right, so those are kind of some just basic steps to get started. We've put a lot of links for you in the chat as well. And one of the comments real quick, and then I'll turn it back over to you, Sarah. Can students use their own data? Yeah, I think, as long as students are of the age and the skill level to be able to kind of look at and make sense of things like trend of data, I think it's a good idea to share. Sometimes, like with a few students I've worked with, showing them their data kind of like really unnerves them. And so just want to be careful, like that you're able to explain to them things like, slope, like not every data point is going to go up, 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 up for every student. So great questions. Turn it back over to Sarah.
All right, thanks so much, Erica. So as we wrap up here, we've talked about the importance of using evidence to guide all of our decisions that go on in our math instruction. And so then we introduced the database decision-making framework, talked about what might be some of the evidence-based practices in that instructional platform, what might be some of the progress monitoring and decision-making things that we should think about to make sure that instructional platform is successful for students. And then if it's not, what are some of the diagnostics we should do in order to make really smart adaptations to that instructional platform? So here are some resources, a lot of them from the National Center on Intensive Intervention, that you might consider using as you design your instructional platform and implement database decision-making in your classroom or in your school. So here, one of the resources is that you can find some more information about database decision-making, or DBI, database individualization. They have some self-paced modules that you can access here so that you learn more about that instructional platform, the progress monitoring, decision-making, and adaptations. As Erica mentioned, one of the really great resources from the NCII are those progress monitoring tools charts. Probably many of you have checked those out in the past, but there you can go and you can see I toggled math, and then it comes up with many of the math progress monitoring tools that you might consider using as you are implementing DBDM. When we think about some of the instructional components, especially as they pair with these assessment components of DBDM, you can also find this intensive intervention and mathematics course. It's all free, and it's from the National Center on Intensive Intervention. There are 8 modules. Each of those have 8 parts, or not 8 parts, I'm sorry, 3 parts. So there are 24 different components of intensive intervention in math. And you can work through those videos and the activities that go along with those videos to really deepen your knowledge about this important framework for students. Alongside that, we've got some materials that are about how to design intervention in math. So here you can check out these documents, and some of the things they dig into are explicit instruction, representations, fluency building, error analysis, all really important topics that we've talked about today. There are also math sample lessons that you can download and use if you are supporting students in mathematics. Some of those revolve around early counting, the operations, place value, fractions, and computation. Probably all of those are things that many of your students might need additional support on. So you can download those free lessons there and check them out. And sometimes there's videos that accompany those lessons. So that wraps up today's webinar. We are very close to the top of the half hour, so we're just right on time. So I just want to thank you. My name is Sarah Powell, and I was joined today by my amazing colleagues, Erica Lemke and Brad Witzel. And now is a time for a Q&A. So if you want to sign off now, we really thank you for being here, and then we're going to stick around for the next 5 minutes. If you do have a question, go ahead and drop it in the chat, and we will answer it now. Thank you very much. Have a great day. All right, so a question has come into the chat, and Erica, maybe you want to take this one. What is a great progress monitoring tool other than CBM? Maybe you want to clarify a little bit about the terminology there.
Yeah, sure. So great question. So there are progress monitoring tools that are, let's give an example, like a computer adaptive tool. So there are some companies who build their tools as computer adaptive. Students can take those on the computer. I wouldn't recommend those for progress monitoring, primarily because they take a lot of time. Like they might take 20 to 40 minutes per week. We don't have time to do that. So when I talk about progress monitoring tools, I equate that with CBM. I am talking about curriculum-based measurement tools. And CBMs have characteristics like short duration, valid and reliable, other types of key characteristics. And so I think about CBM as the best version of ours.
Thank you.
I'm not
All right, one of the
sure-
questions. Yeah,
Oh,
go ahead,
sorry.
Erica.
Like,
Yeah.
this might be an Amy question, if we can send the question and answers, so that they have the notes later. We'll look into that. I don't know.
Yeah, we'll try and figure out how we can do that.
And I think Kelly asked about the link to the video, and I think you will receive that. If you registered for the session, you'll receive that later.
Yeah, so we'll be posting, I'll post it again in the chat for all of you now. It's going to be the same place where the slide deck was that I posted early on in the presentation that you could access. You can access that right now. We'll work on pulling down the recording, clean it up a little bit, take off that front end matter because you don't need to learn about Zoom every time you want to watch this recording. But we'll go ahead and do that. We'll clean it up. I'm hoping it will be posted pretty shortly within the next week at the latest. And again, you'll get that link hopefully in follow-up communication as well.
Great. Some other questions have come into the chat. And Brad, I'm going to ask this question to you from Jenny. The question says, we have lots of discussion about high school math intervention, and there's two schools of thought. One, focus on foundational skills. Two, preload, pre-teach upcoming units of study. What are thoughts on this from the team?
And I saw that, Jenny, your question is actually one of the more complex ones because it really depends on how much time you are dedicating to the intervention. Now, the reasons why is ideally what we'd love to do is you've got to do a couple things here. One, you've got to shore up those foundations. I have been told by numerous people that they give me grade levels or age levels that certain foundation should go away. And that sounds fine and dandy unless it's your kid. Once it's your kid, you don't give up on certain foundations. In fact, you never give up on your own kid. So I never want to tell anybody to give up on any foundational skill. Here's my thought. You've got to do an intervention based on what foundational skill is impeding their progress towards that grade level standard. Work on that foundational skill one. Practice that foundational skill. Practice multiple interleaved foundational skills. You then need to make time within your intervention, and this is where the time issue comes in. You must make time within your intervention to talk about how that skill or skills impact a future learning. Because what often happens is if you keep always reaching back to what they just learned earlier, we have a motivation issue. And I'll just give you an example. So let's say I'm working with Anna, and Anna's sitting there and she really likes Mr. Witzel, and Mr. Witzel's really helped her out. She starts learning that Mr. Witzel is going to reteach something that comes from core. You know what's going to happen? She's going to be polite, sit there and try to pay attention a little bit to the whatever algebra class, and then she's going to go to me and go, how do I do this? Which means every day she's not attending in that class, I am going to have in a condensed amount of time have to do the intervention and try to shore up her weakness in that core content. Turn it around and flip it on her. You want her to go into that core content with a background knowledge that she has seen that approach before. So you have to investigate what is happening in the core. How will you teach this core skill, right? Whatever math construct standard there is, show me how you're going to break this down. Great. I'm then going to come in before she sees that in a week or 2 weeks, perhaps how Anna sees that in that instruction, infuse that skill so that when she gets to class, she can attend better. I still have to support how she's going to enact it, but I've got to prep her on it. So I know you asked me an or question, and it feels like a cop-out, but you really can't do an intervention without showing how that intervention impacts core learning.
Thanks, Brad. We have one more question, and I think we'll probably answer this one quickly. Are iReady and NWEA map reliable screeners? How can we best use the data we get from these resources? I would suggest first looking at the NCII tools chart, where they've done an evaluation of the reliability and validity of these different types of screeners. And then if you want to go beyond there, you can always reach out to us and we can answer those questions further. But it is 30 minutes past the hour, so we are finished with this this webinar today. Thank you
Thank you,
again for
everyone.
joining us. Please do fill in the evaluation for this. The NCII really likes to get that feedback. And hopefully you will get an email from Amy Peterson very soon, or else someone else from the NCII that will have this recording and all of these resources that we've talked about. Have a wonderful day.
Bye, everybody. Thank you.
Thank you.